Good morning. Uh, we don't have a new lecture today. We only have the mini lab, and I decided that we can do the English assignment together as well. Okay, so in the circuit shown below, the switch has been open for a long time before closing at t equals 0. Determine an expression for VCST, which is the voltage across the current source. Okay, so this is the circuit, and let's start with Cohen. What should I do first? Okay, at what time you should analyze the circuit?
Before T0.
Yeah, T0 negative. So let me copy the circuit. I don't have the solution with me, so if I needed some calculation, please help me with your calculator. So before 0, it means that this is open, right? And this one, let me make it black. Now, Cohen, what other simplification I can make?
You can add the 6 and 12.
Okay. So let's do it right this. 6 and 12, which is 18 ohms. Yeah. What else?
Did you short the 2 inductors?
I can short the 2 inductors. Let me do one simplification right here, actually, instead of, in the general circuit, the original circuit, I can do one simplification. Can you tell me what that is?
We combine the 1 and the 3 inductor.
Okay, do you see we have 2 inductors? Does that mean that the circuit is second order?
Probably. Yes.
Why not? Because you can combine them, right? If you combine them, it will be just one inductor, so the circuit is not second order. Okay. Did you really expect to do that? Okay. So one way of thinking about this is that, okay, there's no way we can do second order, so there must be some way to combine the inductors, okay? So how can I do that?
They look to be in parallel,
So how do you treat parallel inductors?
like resistors.
So it would be 3 over 4 Henry, right? Do you agree with that? Yeah.
So, whenever you're combining like something that's in parallel, like something like that, where it's not like as simple as just taking the one part off and putting it, like how do you decide where to put the equivalent element?
Okay. Right now, everything okay? So, do you agree that the 3 Henry and 1 Henry are in parallel? So that's obvious? Okay, now, if you really have a hard time okay, that's one terminal of the parallel elements. The other terminal is here, right? So if I combine them and end up having only one equivalent inductor, between which two terminals it should be located? Between the black and the red, right? Did that make it easy? So now, between black and red, I need only one inductor with the value of 100. So if you still have problem, let me do this for you. So, do you agree that my circuit is still the same one?
Effectively, yeah.
Huh? I just relocate the branch including the 300 inductor, but I didn't change the circuit because that is still between black and red. Okay, now what can I do with that? They are clearly and very obviously in parallel. How do you combine two parallel inductors? Just remove one and put the value of the other one as, what was it, 4 over 3? 3 over 400. Did that make sense to everyone, how I did that? Okay, so I didn't change any part of the circuit. So let's do the same thing here. Okay, and combining the 6 ohm and 12 ohm is not applicable to the general circuit. It can only be done here because that branch is open, so they are clearly in series. Okay, so far okay? Now what should I replace the 3 over 400 inductor with? Short, right? So I'm going to remove it and replace it with a short. Okay, so this is my circuit. Now, do I only need to find VC 0 negative, or there is some other variable or some other quantity that I also need to find? What is that? Are you talking about this one? So William is suggesting we need to find this one as well, but the question is not asking for it. It's only asking for the voltage across the current source. So why should we also find this one?
Because that will be the same current or 0 positive.
And?
You turn it into a current source.
Yeah. At t equals 0 positive, what do you replace the inductor with? The current source. And what is the value of that current source? Where is it coming from? From the analysis at t equals 0 negative. So if you don't have that value, you don't have the value of the current source, and you cannot analyze the circuit at t equals 0 positive. Does that make sense to everyone? So you have to, no matter what quantity you're asked to find, always find the current of the inductors and voltage of the capacitors. Always. You can have some other variables in the circuit that you're interested in finding, but this is something that you have to find always. The current of the inductor and the voltage of the capacitor. So let's analyze the circuit. Sorry? Let me see. Oh, yes. Irretomida, right? Can you tell me one more simplification in the circuit? Aruna, look to the right side of the circuit. 4 and 18, what are they? Are they series or parallel? Let me add the third choice, neither. Neither, so you cannot combine them. Jude?
Can you short the 18?
Do you see the 18 ohm resistor? both terminals are connected to the same node. So it's technically shorted. What does it mean? It means that if you have some current coming through here, will that go through the 80 ohm? No. Because this down pass through the inductor is a short circuit, so it will bypass the resistor. So I can remove all of this. Okay? At any point you have a problem, let me know. Tyler, what do you suggest for this circuit?
KVL.
What do you mean KVL?
For the nodes.
Nodal, you mean? Nodal is KCL. Okay? Nodal, yeah, nodal's fine. What's the blue voltage?
In volts.
Tyler, what's the red voltage is 0. What's the green voltage? What do you label it as?
VC.
Yes. I shouldn't write VC, but I don't know why I did. I should write VCS. CS meaning current source, not the capacitor, okay? So I should call it VCS. And yes, let's call it VCS. Or VCS 0 negative, it doesn't matter. So next, how many KCL should I write? 1. KCL at VCS. What is the KCL equation?
VCS minus 10 volt. Negative 5 amps. And VCS minus 0.
Equal to 0.
Or equal to 5.
Yes, if you, yeah, exactly. So VCS 0 negative is equal to, what's the value? 20, 30, 15? Okay, what else do I need to find? Garrett. Perfect. IL 0 negative is equal to 15 volts divided by 4 ohms, which is 3.75 amps. Let me know if I mess up. Okay, we're done with the step 1. Step 2. T is equal to 0 positive. Let me write it in the next page. So let me copy the circuit. Remove these highlights and close this. Let me change the labels to VCS 0 positive. Next, what else should I change in this circuit? Yes. What's the value of the current source? IL0 positive, which is equal to IL0 negative, and it's equal to 3.75 amps. Okay? What do you suggest we do for the circuit?
We can do a couple of super meshes.
Do you want to do nodal mesh analysis? Let's do mesh. So let's call it I1, I2, I3, and I4. Okay, do you see any super meshes? What are the two? Okay. Considering or trying to remember how we could do super meshes, do you agree that I can just make one super mesh out of the three of them? Doesn't make sense. Do you remember how we proved that super mesh is a thing, is a valid thing to do? I added two equations, got rid of the annoying parts, and ended up with one big equation and said, okay, this is associated with the super mesh. Now, can I add three equations? Yeah. And get rid of everything that is annoying us. So, this is one big super mesh. What's the good point about this? Is that you don't have to worry about the current sources. So KVL at super mesh. Can you give me the equation, please? Landon.
Negative 10 volts plus 4I1 plus 4I3
Plus,
6I4
plus 4?
plus 4I3. Oh, I3 minus I2.
Yeah. Plus?
6I4 minus I2 plus 12I4. That's it.
4 equation and 1 unknown. Sorry, 4 unknown and 1 equation. Do we have anything else to write KVL at? Yeah, we do. What is that?
At I2.
Yes.
It's 4I2 minus I3.
So why did you forget about the 6 ohm?
Good question. I don't know.
6 multiplied by I2 minus I4 plus 4 multiplied by I2 minus I3 is equal to 0. Okay? And, okay, 2 equations, 4 unknowns. I need 2 more equations, Mika. Where should I get them from?
Can we get them from the current sources?
We should.
So, like 5 amps is equal to I3 minus I1.
Yes, I3 minus I1 is equal to 5 amps.
And the next one is IL0 positive equal to I3 minus I4.
I3 minus I4 is equal to 3.75 amps. Take out your calculator and give me the results. I don't have it. I don't know how to use a calculator, so you have to help me. I need at least 2 responses so I can trust you. Oh, let me see. I think there is a solution to that. I didn't remember that. And I didn't hide it from you, so let's see, solution guide. Unfortunately, that's done with nodal, so we can't use that. Maybe I can. Anyone? Sorry? Just substitute one of them, make it easier.
I1 is negative 0.5.
Give me 1 second, please. I1 is
Negative 0.588.
0.588.
I2 is 1.721.
1.721.
I3 is 4.41.
4.41.
And I4 is 0.662.
0.662.
I just hit the thought mesh would have been way easier. Not mesh, nodal.
I didn't argue with that. I just respected their decision to do mesh. And it's good to know that whatever you do, it's not going to be crazy difficult, even if that's not the best way of doing things. Okay, so can someone else confirm these values? Maybe I. So let me see. I4, okay. This is for myself, don't write it. There seems to be a mistake. Really? No one is willing to calculate this? You've done it? You have the same values or no? Okay, tell me what that is.
I didn't get I1 yet. I was about to substitute that in. I got I2 equals 2.4375.
2.4375. I3?
4.6875.
4.6875. I4?
0.9375.
0.9375. Give me I1. That's the one that actually I need.
Negative 0.3125.
Negative 0.3125. 5. Okay. Who can confirm these values? You. Okay. Send me an email. I will add 5 points to your final grade. 0.3125 times 4. Yeah, that's the value. Exactly correct. Okay, thank you. So, what do I need to find? I need to find VCS 0 positive, right? These are not the values I'm interested in, but it will help me to find the values. Griffith, you too as well. Send me the email. How can I find VCS 0 positive based on the current values that I have? Whenever you're asked to find the voltage across a current source, you should use Ohm's law to find the voltage, right? 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 Can I use Ohm's law for a current source? No. What is the only thing that I can use to find the voltage across a current source? What is the only thing that you know is associated with finding voltages? KVL. So how can I find the blue voltage in the circuit, provided that I know all the currents? I should find a loop or a mesh that which this is a part of, and then write KVL around it and find that voltage, right? For example, look at the mesh I1. KVL at mesh I1. So, -10 plus 4I1 plus VCS 0 positive is equal to 0. Do you agree with that? So -10 plus 4 times -0.3125 plus VCS 0 positive is equal to 0. From here, I can say that VCS 0 positive is equal to 11.25 volts. Okay? Now, let's go to step 3.
Time constant.
Huh?
Oh, time constant, or will we do?
No, no.
Keep it in first.
Yeah, Mika, what's the step 3? Did I already ask you? Yeah. Joshua, what is the step 3? Yeah. Let's see. Can you simplify the circuit for me? The switch must be closed, right?
Yes, sir.
So that is this one becomes VCS infinity. How about the inductor? Short. What else?
6 and 12 will become parallel, so they become 18, and they get shorted, so they become the same.
So 6 and 12 are in parallel, and what?
They're both terminals, when you combine them, both terminals become, oh wait, no, they're not.
No. Okay, let's start with what you already said, and it seems correct. Do you all agree that 6 and 12 are in parallel? So what is the parallel of 6 and 12? 4? Okay. What else can I do to simplify it? If you have problem understanding this, let me do it in steps. So 6 and 12 becomes 4 ohms. What else? There is one more simplification I can make. 4 and 4 are in parallel. So just be careful not to destroy any of the variables that you're interested in. And what should I write for 4? 2 ohms. Okay, any problem with that simplification process? Okay, so this is also something that I need to find. I forgot to write it. IL at infinity. IL at infinity. And IL at infinity. Okay? So, how can I solve this? What do you suggest, Ty?
For for an inductor, otherwise I would say tau equals the inductor value divided by.
No, I'm not supposed to find tau yet.
Sorry.
First, I have to find the values at t equals infinity.
Yes, sorry.
Yeah. So what do you suggest to analyze the circuit?
I would say nodal ones.
Nodal, yeah. Seems. Okay, so here is 10 volts. Here is ground. And how do you label the black node? VCS. Now let's write KCL at VCS and tell me the equation, please. Next one. Gabriel?
VCS minus 10 over 4. Minus 5. Plus VCS over 2. Or minus 0 over
10? No. Yeah. Is it 10 volts?
Yes.
Yeah. And how about the other one? IL infinity. So IL infinity is equal to 10 volts divided by 2 ohms, which is equal to 5 amps. Okay. Step 4. Cameron. The time constant. Removing the labels because I don't need them. What should I do to the inductor?
Find the equivalent resistance.
from across the terminals that you separate the inductor from, right? So I'm going to remove this. And this is R equivalent, right? Yes?
So you always find the equivalent resistance at T greater than 0?
Can someone answer his question? Why do we find the time constant at T greater than 0?
Because the time constant is a value that helps us calculate how long it takes for the all the current to leave the inductor.
Yeah, because
Change the time constant.
the transient analysis happens at T greater than 0.
We don't care
Before,
about the time.
yeah, before 0, everything is in a steady state. After T equals 0, it starts to decay, right? So what should I do with the sources? Next one.
Sure, the voltage.
Can you, yeah.
Kill them, make the voltage,
How?
make the voltage a short circuit, and the current source an open circuit.
Yeah. Like this, okay? And oh, I forgot to connect this one. This should be connected as well. Okay. Adrian, how do you find the equivalent resistance from the terminals? Is it confusing?
4 and 6 are in parallel,
4 and 6 are in parallel, yes.
and then that would be in series with 4, and then that would be in parallel with
4 and 6 are in parallel, yes, but they are not in series with the other 4. So how can you do this? Let me, whenever the circuit is confusing you, if it is confusing you, start with one terminal of REQ, whatever you want. For example, the top terminal, okay? Here is the top terminal. So this is one terminal. From the green terminal, I should go to the purple terminal, right? And how many paths do I have to go to the purple terminal? From green to purple, how many paths do I have? 2, right? Through the 4 ohm to the 6 ohm. So let's four ohms and 6 ohms. Okay, just to make sure that you're following everything, I'm going to color this as green because I started from the green, now I have moved to purple, right? Now I'm at the purple terminal. What is the next terminal that I should move to? Let's use blue. How many paths do I have from purple to blue? 2, right? 1 is from the 4 ohm and 1 is from the 12 ohm. So one is to a 4 ohm and 1 is to a 12 ohm. So I was here And now I have arrived at the blue node.
It's kind of hard to see the difference between the blue and the purple. But now I can't see it, I can see the
Okay.
It's still kind of tough.
Is it now more
A
visible?
little.
Okay. What else I can use? Let's change the purple to pink. See if did that make it better?
A bit better, but I'd still use something more distinct like that.
Okay. Now, from which two terminals I need to find REQ? From the left terminal, green, and the blue, right? Do you all agree with that? The REQ is between green and blue. So, now Adrian, can you tell me what's the equivalent resistance that you see between these two terminals?
4 and 6 in parallel, and then the series of 4 and 12 in parallel.
So it's going to be 4 in parallel with 6 plus 4 in parallel with 12. Which is equal to
Now it's at 5.4.
5.4. Do you confirm? Next, Isaiah. Tau is equal to? You don't know? Sebastian, tau.
Would be you get the L over R, which is going to be that 0.75 figure over the.
What is L? I don't remember.
L is we made
3.3 over 4.
5 total. Put that over the 5.4 we just got.
And what's the value? 5 point? Or you know a ratio? Oh, okay. Like this? Okay. Based on this, I can also write 1 over tau, and that is in second, right? Yeah, because I didn't have. So, 100 seconds. 1 over tau, it's going to be 6 over 12? Huh?
36 over 5.
Yeah.
Something like that.
36 over 5, which is 7.2. I said 6 over 12.
The reason I gave it those corrections is the sheet asks, or gives it.
Oh, sorry. Yeah, thank you. Okay. What's the last step?
Now add it all out.
I'm only interested in VCST. So, what's VCS 0 negative?
15 volts.
15 volts. What is VCS 0 positive? 11.25 minus, what's the value at infinity? 10? Okay. Any question, problem? No? Did we get the same thing? Start the mini lab, please. Yeah.
I was wondering, when we went and did that P infinity, the values we got are the same values as before. That's not always going to be the case, right?
No. Just accident.
Just a question.
Yeah.
And even then, it's good to check, to be certain.
Yeah.